Good morning, students. Welcome to chemistry class. Today, in this video, we are discussing about the from haloalkanes and haloarenes chapter. Stereochemical aspects of nucleophilic substitution reactions. Stereochemical aspects of nucleophilic substitution reactions. So, in this, we're discussing some basic principles and notations. In that, first one is over. That is plane polarizing light. Plane of polarizing light and optical activity is over. Today we will discussing about molecular symmetry and chirality. Molecular asymmetry and chirality. Molecular symmetry and chirality. So here, symmetry. What is the symmetry and what is the chirality? Or what is asymmetry? Asymmetry, symmetry. Symmetry means plane of symmetry. So plane of symmetry means, what is plane of symmetry? Symmetry means when any one of the compounds, when cut it, that gives equal halves. So that is called plane of symmetry. In one direction, when one direction will cut, that gives equal halves. That is plane of symmetry. Suppose this duster, when it cut it, correct this angle and it gives equal halves, that is a plane of symmetry. Like this. So which scientist is observed, and according to them what is the asymmetry, and we'll know it in this video. So here the observation of Louis Pasteur. This is one of these scientists, and 1848 the crystals of a certain compound, observe the crystals. Here the crystals of certain compounds exist in the form of mirror images. Laid the foundation of modern stereochemistry. He demonstrated that aqueous solutions of both types of crystals showed optical rotation equal in magnitude but opposite in direction. So he demonstrated that aqueous solutions of both types of crystals showed optical rotation equal in magnitude if they having same or equal concentration, but opposite in direction. The rotation will be opposite in direction. One direction levo, another one direction is dextro. Means one is left side, another one is right side. So equal rotation. The magnitude is equal. That magnitude is the magnitude of rotation in opposite direction. That means right and left side, when passing through the plane polarized light through the solution, the rotation will be equal. So that such solutions, the solution is what is that? He believed that difference in optical activity was associated with three-dimensional arrangement of atoms in two types of crystals. So he believed what is that? That arrangement of the atoms in two types of crystals. Two types of crystals means what? One is the left side, another one is the right side. But one compound, when it gives the in mirror image, suppose this duster, the mirror image is another image. So that is two crystals. So in opposite directions, we believe that difference in optical activity was associated with the three-dimensional arrangement of atoms in two types of crystals. So that is 3D dimension, two arrangement of crystals. Suppose one carbon arrangements in three-dimensional. So one is the methane. Suppose we have to take the methane. What is the methane? Carbon having four hydrogens attached to it. So that is the central. So like this, that is a tetrahedral. So like this arrangement of like this. So one is above like this. It is a tetrahedral. So each bond angle between the 109.28 degree, 109.28 degree arrangement of this like this. So methane when it is mirror image, it's the same. That is also a different. One is left side, another one is right side. One is levo, another one is dextro. So the two types of crystals are they have 3D arrangement. So another one thing is in this matter discussing or argued between the some scientists, that is Dutch scientist J. Van't and French scientist C. Lebel in the same year 1874 independently argued the spatial arrangement of four groups around a central carbon. Is tetrahedral if all substituents attached to the carbon are different. Such carbon are called asymmetric carbon. So arrangement of four groups around the carbon atom. Then this is a tetrahedral carbon or sp3 carbon. sp3 carbon having which shape of tetrahedral carbon. So if all substituents attached to that carbon different, the such carbon are called asymmetric carbon. So the carbon is also called stereo center. You know already like this. So one is methane. Suppose methane. So hydrogen. So this is a stereo center. So all these different groups, not hydrogens here. So if it is all are hydrogens, that is called a plane of symmetry. Why? Because methane will take the methane. So when cut it, so it gives 2 halves. When cut it gives 2 halves. So that's why this is followed plane of symmetry. So this carbon is not asymmetric. And another one thing is when chlorine and another one is like this, all this. So here, plane of symmetry that along with the chlorine, carbon, hydrogen, and it gives equal of. It gives equal of. So this is also not a followed asymmetric. And also when it is taking another one here Br, another type Br. So when it is through this, it gives equal of. So this is not a asymmetric carbon. And when take iodine, chlorine, bromine, iodine. When take here iodine, so it followed asymmetric. Why? Because all iodine, chlorine, bromine, hydrogen, all these different. So that carbon is a asymmetric carbon. So resulting that the molecule, the compound, that molecule gives asymmetric molecule. So this is the asymmetry. Asymmetry means here symmetry and asymmetry. Symmetry means when objective is equal. So symmetry. Suppose when mirror, this is a sphere. When it is in mirror images of same, and this is one of the cube, and here also the same like this. So that's why. So whatever way, this is symmetry. And another one asymmetric followed hands. So this is a left hand. In a mirror image, it will be as a right hand. In mirror, when we see in the mirror, that is a right hand. And this is right hand. In the mirror, this is a left hand. So same thing. These are the it is a when mirror is a mirror image, and mirror image active as it is, and the same in the position. So it is a asymmetric. So non-superimposable. Suppose when sphere taking as it is, that is as it is, the fixed in the diagram. So that is a symmetry. So like this, non-superimposable, superimposable and non-superimposable. Superimposable means what? What is superimposable means? A similar structure in its mirror image. When it's mirror image, that is superimposable. That mirror image is called superimposable. A different mirror image, when it is the placed on the over on that gives non-superimposable. Suppose this is a one hand. When it gives mirror, that is right hand. So right hand it gives exactly like this. Not the same. Why? Because this is a thumb finger, this is indicator, this is middle finger, this is a ring finger, this is a small finger. So like this, when it is attached, when this placed on this as it is laid, so not a different. Why? Because like this. This is one hand, and this is another one hand. This is the mirror image. So when it mirror as this gives like this. So when it is placed on this, so it is not superimposable. Suppose when ball we have to take like this. In its mirror images, when keeping on this, that gives the same. So that is the superimposable. This is the non-superimposable. So here the objects which are non-superimposable, on their mirror images are said to be a chiral molecule. And the resulting property is called chirality. So So here what is that? The object which are non-superimposable, on their mirror images are said to be a chiral molecule. So that resulting property is called chirality. The resulting property is called chirality. What is chirality and what is chiral molecule? Chiral molecule, the objects which are non-superimposable on their mirror images are said to be a chiral molecule, and the resulting property is called chirality. So chirality, it should be contain asymmetric carbon atom. It should be contain asymmetric carbon atom. What is asymmetric carbon atom? Means the carbon atom must have four different atoms or groups. That carbon is called asymmetric carbon atom. The carbon is called asymmetric carbon atom. So when plane of symmetry, the compounds which are followed a plane of symmetry, that gives the type of carbon having that is not a followed chiral, So that carbon is called achiral carbon. Achiral carbon means what? The carbon not a followed asymmetric. Means that should be two or more same groups attached to it. So here this is achiral carbon. Why? Because all is same group attached to carbon. And another one thing is, see, so these are achiral carbon, right? Because these two similar. This follows plane of symmetry. That is achiral carbon. So carbon must have different groups. That is a chiral carbon. Or asymmetric carbon means must be a different group attached to the carbon. That is asymmetric carbon. So this is the here you will see the symmetry and the asymmetry. So hands, feet in mirror images, you may know about the or understood the asymmetry and symmetry. So thank you for watching this video.